Every human body acts as a continuous thermal reactor, radiating ambient heat in the form of infrared energy. When you apply the LifeWave X39 patch to the skin, it doesn't push any active pharmaceutical ingredients into the bloodstream. It is strictly a non-transdermal device. No chemical compounds enter the body. Instead, the patch functions as an optical transducer. It captures that naturally occurring broad-spectrum infrared emission. The patch's internal spectra filters this energy, bouncing it back into the epidermis as specific, concentrated wavelengths of light. This targeted optical stimulus triggers photobiomodulation. The skin's photoreceptors absorb the directed light, turning a physical wave into a cellular signal. Clinical trials indicate that this localized light absorption does not stop at the surface of the skin. It initiates a systemic biochemical cascade. The primary catalyst in this chain reaction is a highly significant elevation of a specific copper tripeptide circulating in the bloodstream, known as GHK-Cu. GHK-Cu functions as a signal-modulating peptide. Upon entering the cell nucleus, it alters the transcription of over 4,000 genes, reverting their expression to a more youthful, restorative baseline. Double-blind, randomized controlled trials confirm that applying the X39 patch elevates these GHK-Cu levels within 24 hours, with sustained increases measured at 7 days. By utilizing specific light reflection, the patch initiates an endogenous response that prompts the body's epigenetic machinery to begin systemic repair. Once GHK-Cu levels rise in the blood, we can track exactly how this peptide physically alters the body's immune defenses. This chart tracks GHK-Cu concentration. You can see a distinct upward trajectory moving from baseline through day 2 and rising sharply by day 7. The elevation at this 7-day mark reaches a statistical significance of p less than 0.035, confirming a measurable biological shift. To observe what this elevated peptide actually does, researchers conducted ex vivo stress tests on the subject's blood samples, subjecting the cells to intense oxidative and inflammatory environments. They focused specifically on the primary defenders of the immune system: lymphocytes, monocytes, and neutrophils. Inside these immune cells, the mitochondria, the metabolic engines that generate cellular energy, began reproducing and expanding in physical volume. This is a process called mitochondrial biogenesis. Under severe stress, a cell with a larger, more robust mitochondrial network can sustain its energy output without collapsing. The initial optical signal ultimately builds greater physical resilience into the immune system, allowing these cells to survive and function under heavy biological attack. With stronger immune cells in circulation, we see an immediate shift in how the entire immune network communicates. We measure this communication by tracking a panel of cytokines. This diagram illustrates changes in immune markers. The blue line representing C-reactive protein, a systemic inflammation marker, drops sharply below baseline. Simultaneously, the red line tracks a decline in pro-inflammatory cytokines, while the green line surges upward, indicating increased anti-inflammatory cytokines. This surge includes PDGF-BB, a critical growth factor that directs blood vessel formation and tissue remodeling. The data shows a coordinated pivot. The body is downregulating its aggressive inflammatory attack mechanisms and upregulating its cellular repair systems. Sustaining this level of systemic repair requires fuel. To find out where that fuel comes from, we have to look at the body's metabolic chemistry, specifically its circulating free amino acids. Metabolic assays revealed a specific chemical anomaly. Blood tests showed rapid depletions in the available pools of glycine and glutamate. The body routes these amino acids into the transsulfuration pathway to synthesize high volumes of a complex molecule called glutathione. Glutathione is the liver's master antioxidant. It is the primary compound responsible for purging heavy metals from blood and protecting the central nervous system. The depletion of glycine and glutamate proves that the optical signal forces the body to consume its raw reserves to manufacture a systemic protective biological shield. This deep biochemical optimization directly impacts the central nervous system. To measure how this neuroprotection alters brain function, researchers used P300 quantitative EEG brain mapping. Looking at this baseline topographical brain map, we see areas saturated in reds and yellows, indicating hypercoherence and stress. After weeks of daily patch application, the intense reds and yellows dissolve into organized, calm zones of blue and green. This color shift translates to a measurable normalization of P300 voltage. The excessive electrical noise clears, leaving a physically calmer, more efficient brain state. This electrical calming correlates directly with cognitive performance. Subjects were evaluated using the WAIS-3 memory test alongside the brain mapping. The results showed highly significant improvements in short-term memory function within 7 days of use. The brain is a direct beneficiary of the biological cascade. By optimizing metabolic chemistry and reducing inflammation, the nervous system achieves a higher level of cognitive clarity. If we scale back out from the neural pathways through the bloodstream and return to the surface of the skin, the scope of the intervention becomes clear. The X39 patch introduces 0 external chemicals into the body. It relies entirely on reflecting the body's own endogenous infrared light. That specific optical reflection elevates GHK-Cu, which triggers mitochondrial biogenesis, drives glutathione synthesis, and organizes electrical coherence in the brain. As a result of this microscopic efficiency, clinical trials document a series of macroscopic health outcomes, including reduced blood pressure, improved sleep architecture, and measurable increases in physical vitality. The clinical data confirms these physiological outcomes through objective measurement, reaching statistical significance across the 7-day study period. By directing a highly specific wavelength of light to elevate a single epigenetic peptide, the body receives the precise biochemical instructions it needs to repair and optimize its own cellular machinery.